Good morning one and all. Welcome to the video lecture series on soil mechanics. This is lecture number 4 today. Yesterday we have stopped at relationship between E and N. Relationship between void ratio and porosity, E and N. Now today we are going to discuss these relationships. E is equal to VV by Vs and N is equal to VV by V, total volume. Now we have to express E in terms of N. So to express E in terms of N, we have to divide both numerator and denominator with V, because the N is containing VV by V, denominator is V. So we divide both numerator and denominator with V, Vs by V. Now numerator became N and denominator is volume of solids, total volume minus void volume divided by volume. E is equal to N by 1 minus N. The relation. Now, express N in terms of E. N is equal to V by Vs. We have to divide with Vs because we have to express N in terms of E by V by Vs. N is equal to VV by Vs is E. V means total volume VV plus Vs divided by Vs. E by VV by Vs is E plus 1 or E by 1 plus E. N is equal to E by 1 plus E. You can put it in box like this. N is equal to E by 1 plus E. This is the relationship between E and N. And N and E we have seen. These are the relationships. Now, we have seen yesterday derivation of ES is equal to WG using different methods. SE is equal to WG. I will derive all the methods, 8 methods, so that yesterday we have seen 4 methods, today we will see remaining 4 methods, so that there will be no problem at all for anyone. So take for first variable S. S is equal to VW by VV. We know that E is equal to VV by Vs. So we can express VV in terms of Vs as VV is equal to E times Vs. S is equal to VW by E times Vs. Yes, we have expressed it. We know that V is W by gamma from the earlier lectures. S is equal to 1 by E into WW by gamma W into gamma S by Ws. S is equal to 1 by E. WW by Ws is water content. Gamma S by gamma W is specific gravity. So SE is equal to WG. This is method number 5. Earlier we have discussed 4 methods. This is method number 5. SE is equal to WG. Now, 6th method. Method number 6. Same relationship, but method is different. Method 6. E is equal to VV by Vs. Now S is equal to VW by VV. So VV is equal to VW by S. We can write like this. So E is equal to VW by S into 1 by Vs. E is equal to 1 by S into VW is WW by gamma W by Vs means gamma S by Ws. E is equal to 1 by S into WW by Ws is water content. Gamma S by gamma W specific gravity. Es is equal to Wg. This is method number 6. Method number 6. Now another method number 7. Es is equal to Wg. Now take water content W. W is expressed as weight of water to weight of soil solids. W is equal to mg. We know the formula. W is equal to mg. Mass into gravity. Here there is no effect of gravity, so mass and weight are same. Generally, what is the difference between mass and weight is, mass is the amount of matter contained in a body and weight is the due to amount of gravity. What is gravity effect will come into picture in case of weight. But here no effect of gravity, so both are equal. Mass of water by mass of solids. Density is equal to mass by volume from fundamental property in fluid mechanics. So mass is equal to density into volume, rho W into VW by rho S into Vs. We can write like this. W is rho W by rho S is reciprocal of specific gravity 1 by G, because G is rho S by rho W into VW by Vs. W is equal to 1 by G into, we can write like this, VW by VV into VV by Vs. We can multiply and divide with VV in order to make our calculation simple. VW by VV is degree of saturation, therefore WG is equal to SC. Method number 7. By using mass of water to mass of solids. Next, method number 8. Using specific gravity, we will derive this expression. G is equal to gamma S by gamma W. G is equal to gamma S by gamma W, or rho S by rho W. Rho S by rho W, density of substance to density of water. Density is equal to mass by volume. Same expression. Rho S means mass of soil solids by volume of solids into volume of water by mass of water. Mass of solids to mass of water is reciprocal of water content. VW by Vs again. So G is 1 by W into VW by VV into VV by Vs. We can write like this. Wg is equal to, this is S, this is E, Wg is equal to SC. So these are the 8 different methods we have seen to derive the single expression SC is equal to WG. All these are useful in the problem calculation. Now, we have seen from the earlier lectures that a soil particle is formed from the deposition of the rock due to decomposition of the rock. The rock will undergo decomposition and soil particles are formed, and soil particles are deposited at one place. So the mineralogy, suppose take this is a soil, all the amount of minerals present in the soil is known as soil fabric. This is structural arrangement of the minerals inside the soil. All the minerals are arranged in the deposits. This is called soil fabric. The structural arrangement of all the minerals in a given soil mass is known as soil fabric. So this deposition of the soil also depends upon the environment also. Earlier we have seen depending on the marine environment, it is called marine soil, marine deposit, on the lacustrine lake deposit, etc. So soil structure says there are two types of major soil structures. One is flocculent structure and second one is dispersed structure. Flocculent structure and dispersed structure. This flocculent structure depends upon the type of environment also. In the freshwater lake environment and salt water generally this flocculent structure will vary depending upon the salt water, freshwater orientation, like that. Dispersed in the flocculent structures, particles orient like this, edge to face orientation, perpendicular like this, edge to face orientation. This is the edge, this is the face, edge to face orientation. Dispersed structures, particles orient themselves in parallel manner. This is in case of dispersed structure. So flocculent structure also depends upon the type of environment. That's what we have to take care. Once in SSC JEE examination, they asked the question in freshwater lake how they vary, in saltwater lake how they vary. All this we will give I will give one notes type, small key points I will write for that. Freshwater how it will vary, and I will provide the key notes, key points. In saltwater environment, particles orient parallel to each other. In saltwater environment. In freshwater environment, freshwater environment perpendicular to each other. Both are in case of flocculent structure only. Flocculent. In case of flocculent only depends upon the type of environment. So an environment under which deposition occur also influences the type of the soil. Generally, you see the structure of a clay. Clay is made up of three different type of minerals. Three different type of minerals. Clay is made up of three different type of minerals. One is illite, second one is kaolinite, and third one is montmorillonite. Montmorillonite. This montmorillonite is also known as expansive clay. Expansive clay or quick clay you can call. This montmorillonite is a mineral which has more swelling properties. Generally, black cotton soils in India, this mineral is present mostly in case of black cotton soils because they exhibit swelling and shrinkage characters. Kaolinite is illite. All these minerals are present in a clay-like structure. Clay also has adsorbed water. Adsorbed water means we can see that like this dot is adsorbed on the board. Adsorbed. A-D-S-O-R-B-E-D. Adsorbed means attached. All the letters I am writing on the board are attached on the board. Absorbed means that is different. Sponge. Sponge absorbs water. That is the main difference between adsorbed and absorbed. This clay has adsorbed water. Means suppose this is a clay particle. All the water is present inside the clay. Generally, if you see clay particles, if you touch them, they are very soft clay particle. But when it is subjected to drying, this clay particle become very hard. So this film of water is present in the clay particles. This film is coming due to the electrochemical actions. Electrochemical actions. Generally, for all fine-grained soils, we can take a note point like this. Note number 1. For all fine-grained soils, there is negative charge. Surface negative charge on the mineral, on the soil mineral. There is a negative charge. So these are the charges, charged particles. So diffuse double layer, that layer is known as diffuse double layer. The diffuse double layer is present inside the clay. This is important for competitive exam. Just in brief knowledge is important. Don't go in depth for this chapter. Don't go inside the soil structure, geology, all these mineralogy. Because all these are not for civil engineers, for geological people. So diffuse double layer is present inside the clay. All the fine-grained soils, there is a surface negative charge on the particle. That's all. You keep this in mind only. Because don't go deep into the subject and worry. This particle is enough. Okay, winding up the session today. Today what we have learned is relationships E and M, porosity and void ratio relationships, and different methods we seen to derive ES is equal to WG, and also we seen flocculent structure, disperser structure, depending upon the type of environment how they vary. Okay, all of you please like this channel and subscribe the channel, and also share with your friends, because I am preparing so much, because there are some students in our country who cannot go for coaching centers but are serious in preparing and are worrying how we can go for coaching center, we have no money. For them, please, it is very helpful. For everyone, for fresh graduates also, this channel is very helpful in building up their career. So many derivations I am deriving. So it will be helpful for everyone to learn, grow and inspire themselves. Okay, all the best. Thank you.